Okay, so we left off yesterday. You guys had done a really nice job in your groups of coming up with some general ideas of how, when you perform resistance training, how how much, and in some ways, how quickly you might increase the size of your muscles. Okay, so what we need to get at today is the other side of that. Okay, is one of the ways when you do resistance training, your muscles get bigger, and so that's going to make you somewhat stronger. But then there's also going to be changes that take place within the nervous system. So your brain becomes better at sending signals to the muscle and telling that muscle to turn on its motor units and be able to generate force. So um, from a big picture standpoint, if you were to start training right now and train until, say, maybe the middle of September, so 3 months from now, you would have the capacity, most of you would, to increase your strength, your maximal strength, somewhere between maybe 25 to 100 to 150%. Okay. So a lot of that increase in strength is going to be dependent upon whether you are in any way, shape, or form trained at performing that movement right now. So if you've already been training and we have you start doing some more, you're going to gain less strength than somebody that's never ever trained before in their life. Okay. So um, for example, if we took all of you next Monday and we started doing bench press, because Monday is bench press day, then we would have you guys, and we did that 2 or 3 times per week for the next 3 months. A lot of you, if you've never done bench press before, could, if you could lift 100 pounds this coming Monday, then we could probably get you somewhere between maybe 175 to 200 pounds over the course of the next 3 to 6 months. Okay, so a couple of things to note about this is that the gains in strength and, for the most part, the gains in muscle size are going to be similar between men and women, between old people and young people. Okay, so as long as we compare everyone to where they start. All right, so that will become a little bit more clear today when we talk about how we test how strong a person is. But if we know what your initial maximal strength is, and then we train you, and we know what somebody else's initial maximal strength is, and we train them, then we have a way to make a more accurate comparison. If you've got a great big football player who can lift, say, 300 pounds, and then we have a small gymnast and she can lift 100 pounds. But if we train them, then over time, from a percentage standpoint, they should be able to increase their strength in a reasonably similar manner. Okay. So for the longest time, we thought that was one of the reasons that we thought that women could not increase their muscle size or increase their strength to the same extent as men. Sorry, ladies. Again, science has underestimated you guys for forever. But we weren't normalizing people's values to where they were starting. And so it was just, oh, well, the guys got 100 pounds stronger. The girls only got 70 pounds stronger. So clearly the men have a greater capacity. But that was not actually the case when you compare them to their initial strength. And that will become a little bit more clear once we figure out how we assess that strength later on today. Okay. As I said, 2 components in your strength gains. There's changes in the nervous system, which we call neural adaptations. We increase the ability to turn on or recruit whatever muscle or muscles that you're using that you currently have in your body. Okay. And then there are the increases in muscle size, which we term contractile protein adaptations. And so this is also sometimes called hypertrophy. Okay, an increase in muscle size is called hypertrophy. So this is just your muscles will get bigger. If you have a bigger muscle, it has more actin and myosin, therefore it can, in theory, form more cross bridges, and so therefore it should be stronger. Okay. So we talked yesterday that it may take 6 to 8 weeks for contractile proteins to adapt. to see a measurable increase in muscle size, it may take 6 to 8 weeks. It's a very frustrating thing when you're the one that's trying to train, okay? The neural adaptations, on the other hand, happen really, really fast, okay? If you go and you work out today, we have you do some kind of a lift today that you've never done in your life, okay? Whatever that's going to be, you will very likely be stronger or be able to do more repetitions with the same weight on that lift tomorrow than you could today, okay? That is, your muscles haven't gotten any bigger, nothing has changed, but the brain has learned a better way or a more kind of efficient way to turn on the muscle that you have and perform that activity, okay? Think of this as the idea of, I did something on one day and I felt very uncoordinated doing it, and then I did it the next day and I felt more coordinated. It was not quite as difficult. It's the same idea, but it's applied to lifting a weight or doing something like that. Okay, so neural adaptations happen very, very quickly. And as quickly as like the next day or the next couple of days after doing a single bout, right? So if you are a person that has not had a lot of history, okay, doing resistance training, or maybe you've had some history but you've not been doing much of it in recent memory, so maybe in the last 6 months or so, people that are quote unquote a novice at a particular lift will get really strong really fast. They have these very, very rapid increases in their strength from these neural adaptations in the first, say, month or so that they're performing those lifts, the first month or so that they're working out. And so they get this rapid increase in strength, and then the increase is going to level off some, and it's going to go up at a much slower rate because it's going to take a little bit of time after that first, 6 to 8 weeks for your muscles to get bigger. And then as those last bits of neural adaptations are going to be much slower. You get a big thing at first from a neural, and then it's going to slow down. And then you begin to get a little bit of hypertrophy and then a little bit more neural, and so it kind of big rapid increase, and then it's going to level off and go up a little slower. Okay. So just some visuals for those of you guys that like those. These are MRI images of a person that had a spinal cord injury, and this was taken at about the midpoint in their thigh. And so what you can see here, this very bright area that I've got the cursor over right now, that's the bone marrow in their femur. The dark area around that, that's the mineral, the bone mineral in their femur. You are looking at this up through the person's feet. So this is the person's left leg. This muscle that you can see right out here, I know it looks like a piece of steak, right? You guys realize that steak is just muscle. That's what you're really eating when you eat steak. But this is the vastus lateralis here. This is the vastus intermedius. This is the rectus femoris. This is the vastus medialis. These little structures here, that's the femoral artery and the femoral vein. We've got some hamstrings and things that are going to be down here, and then this bright area around the outside, that is subcutaneous fat tissue that we have. But what you can see is these were individuals that had a spinal cord injury, and we had them do some knee extension exercise. So they sat on the edge of their bed, they strapped weights around their ankle. We put these big electrodes on their thigh. Again, sorry everyone, Dr. Black's thigh here. I know nobody wants. We put electrodes on their thighs. We ran current electricity into their thighs, made their muscles contract, and they did knee extension like on their bed. They did that 2 days a week for 6 months. And you can see how much bigger their muscles got just from doing that small amount of things. So this is the ultimate in people that are sedentary. They cannot move those muscles. They cannot move things below their waist. And so they were able to get quite a bit of hypertrophy. Okay, so this is just how we would measure it and what those things might look like. But you will note that we got a lot of hypertrophy in the first 3 months, and then it kind of slacked off some from there. Okay, so we did those things. We've talked about that. So how do your muscles get bigger? And I know that Judy asked a really great question yesterday about steroids and what happens if you take anabolic steroids. And so just to kind of briefly skim over the idea behind all of that is for a muscle to grow, for a muscle to get bigger, it needs to be able to make and then deposit more protein, specifically actin and myosin, into that muscle. Okay. All muscles, really all cells, have the capacity to generate new proteins. That capacity is held in their nucleus. And so what you need is you need to send a signal to your muscle cells that's going to be picked up in the nucleus of those cells. And the nucleus will then unzip and open up its DNA, and it will make messenger RNA that will say, make more actin, make more myosin. Those messenger RNA are going to go off to a ribosome, and then that ribosome will take amino acids, and it will undergo something called protein synthesis. Now, I assume that you guys probably covered protein synthesis in physiology or in your intro to biology class. We're not going to go into some of the fine details of it, but just know that in order to have a muscle get bigger, that muscle must make more protein. And so we're going to use resistance training, and then we're going to also use eating protein in our diet as the kind of stimulus, if you will, or the initial signal to tell those muscles, to tell the nuclei in those muscles, hey, make more actin and myosin, make this muscle get bigger. Okay. The idea behind that is that when you lift weights and you make that muscle generate lots of force, that it puts stress on the muscle. The muscle gets pushed and pulled, and the membrane gets moved around as you're doing that lift. Okay. And as that happens, it disrupts the homeostasis in those muscle cells. The body does not like that. And so in response to that disruption of homeostasis, the muscle thinks, if you will, let's make more actin and myosin. Let's make our muscle get bigger, so when we lift that same weight again, it's not going to cause as much disruption. It's going to be easier to do in that muscle, and therefore it will have less of a chance to have things go badly. Okay? So you work out, you eat protein. When you work out, you're going to release some hormones. You're going to release testosterone. You're going to release growth hormone. You're going to release something called IGF-1. So when you see these anabolic hormones, GF stands for growth hormone, comes from the anterior pituitary. And then IGF-1 stands for insulin-like growth factor 1. Your muscles and your liver make this. Collectively, these are the three primary anabolic hormones. But you work out, these things increase in their production, and they're going to help signal to the muscle to tell that nucleus, let's make some more actin and myosin. Okay? So it typically increases this expression. So if we use the resistance exercise to raise our hormone levels, that's the reason why if you take, we just inject you with testosterone or we inject you with growth hormone. Although it's not exactly that simple, it's a little bit more complicated, but if you just take it exogenously, then you can potentially get bigger muscles, or you should get bigger muscles because it activates that same process. Okay? The other piece of protein balance is how much protein are you eating in your diet? So I will ask, do we have any vegetarians? Anybody in the class a vegetarian? No? Nobody? Okay. So my wife is almost a vegetarian. And so all of you, if you're not a vegetarian, if you eat a relatively kind of quote unquote normal American diet, then you're eating chicken and fish and some kind of red meat, right? Steak or hamburger or turkey or something. Then when you eat those foods, or you eat peanut butter or you eat eggs, they have protein in them. the protein is consumed, it's broken down into these individual amino acids, and then those amino acids are available to not just your muscle, but every other tissue to be able to be incorporated to help make new protein. And so if one of the responses to resistance training is to make your muscles bigger, then if you're eating additional protein, you've got plenty of amino acids available if the muscles need them in order to try and grow. Okay? If you're not eating enough, then what happens is that the protein needs to go to the muscles, so the body will break down protein in other tissues to make the amino acids, and then it will give those to the muscles. And so it's not a particularly good trade-off. This is why, oh, Corey, I thought you were about to pick up a protein shake. That would have been perfect timing. This is why people take supplemental protein, okay? I don't know how much money Americans spend on protein supplements, but it's probably in the billions of dollars a year. This is one of the things that all the bros are taking before they work out, after they work out. If you go to the gym and you see them, this is what they're doing. They have these giant tubs of protein. For most people, the vast majority of people, it's a total, yes, there we go, Jordan. Syntha 6. I've not seen that one before.
I don't know. I think it's one of my roommates. I use VPN though.
Okay. So I don't want to condemn anyone for taking the protein. It's probably not going to hurt you. Okay? There's no evidence that it's bad for you, that it's bad in your kidneys, you have a hard time processing it. But for the vast majority of people, you get a sufficient amount of protein in your diet. And so you pay all of this money for this extra protein. You get very little additional benefit from a hypertrophy standpoint from it, and your body just excretes all the extra. And so what you end up doing when people that take protein, a lot of protein, is you just have really expensive protein-dense urine. And so now, if you resistance train every day, and you're running and doing or some kind of cardio on top of all of that, right? And you're trying to gain weight all at the same time, then depending upon how your diet looks, you may need a little bit of a supplement. If you're an older individual, right? You're maybe over 65 or 70 years old, and we're worried about you kind of losing muscle mass over time as you age. In those instances, taking a supplement may be beneficial, but the vast majority, and what the supplements tell you to take, is way too much. So most people that take the supplement don't really need it. So it doesn't hurt anything, but if money's tight, then you know, we probably don't need that. Okay. All right. So that's the idea of protein balance. We talked about hypertrophy in the time course of hypertrophy some yesterday. We talked about, are there limits to kind of how big you guys can get in the midst of everything. We talked about hyperplasia. We talked about those things. Okay. So I want to finish up today with talking about a couple of other tissues, talking about bones and connective tissue and their responses to resistance training. So in addition to your muscles getting bigger, one of the things that's really, really good about performing weightlifting and resistance training is that you also get adaptations in your bones, your skeleton, and you're also going to get adaptation in your tendons and ligaments. Okay, so we will talk about that. One of the biggest issues, especially in older women, is something called osteoporosis. It's a lack of, or the diminishing of, minerals in bones, especially postmenopausal women. They lose a lot of the signal that helps keep their bones healthy when they lose estrogen, and so therefore their bones are going to become much more brittle, much easier to break. That's why when grandma falls over, she breaks her hip. Well, one of the ways to counteract a lot of that, and that can help you guys now at this point in your life to get as much bone mineral density as possible, is resistance training. Every time you move, every time you contract a muscle, I'm not that strong, but if I was to do some curls like this, okay, I'm doing curls or I'm doing some kind of a tricep extension, that force that's getting applied through the ligaments and tendons to help me move is also being applied to, say, the humerus and the radius and the ulna. And that force creates these kind of very, very low level bends in the bones. Even the giant femur, as you do squats and things, there's some stress on there. It's going to bend ever so slightly. As it bends, that sends a signal to the bones to begin to deposit more and more calcium into those bones to make the bones bigger and stronger so that they won't bend as much the next time. As you get stronger, you need stronger bones so that you won't bend and break your bones, right? This usually goes over a little better when we're in person because I can do some demonstrations. But I showed you guys the pictures of those of the spinal cord injured guys' MRIs, their thighs. One of the other things that we did in one of those guys was we broke his femur. And we actually were doing a knee extension exercise, and as they become so sedentary and they unload, their bone mineral density also goes away very, very rapidly. So we were trying to do knee extension on him, and we snapped his femur in half, basically. Luckily, it happened at a hospital. There were doctors that were right there, and the guy couldn't feel it. But you all don't normally think about that you could, like when you're doing a squat or a knee extension or you're running or something, that you could break your femur. I had a girl in summer school that was she threw the javelin on the track team a couple of summers ago, and they were doing a thing at practice one day, and she was just running, and she broke her femur from running. And she was somebody that had done a bunch of resistance training, so it's just kind of these freak crazy accidents. So bones get stronger, they deposit more mineral. So this is really, really good. So ladies, if you've done resistance training up to this point in your life, that's great. If you haven't, I would really, really advise you to start doing some, because you only have maybe another 7 or 8 years to really try to build up your bone mineral density before, as you get into your early 30s, we're going to start to see the beginning of the taperings off of your estrogen levels, okay? Guys, it's less of an issue for us because we don't have estrogen, but mineral density is good. Bones are slow to adapt, though. Bones take maybe 6 to 12 months to see measurable increases in bone mineral density. So you have to do things for a very, very long time, even longer than it takes for the muscle to adapt, okay? Anybody have questions about what happens with your bones?
I have a question.
Of course, Kylie.
So, like the boxing and the like MMA fighting, do they just like train their bones, or like, I guess, apply so much force that their bones are like super strong? Because like they get kicked in the shin and stuff, in the face and everything.
They do apparently get kicked. I'm not a big hand-to-hand violence kind of person, unless I'm playing like old school Mike Tyson's Punch Out on old school Nintendo. So I don't watch a bunch, but I'm familiar with the idea that they hit each other and they kick each other. A lot of that in the places where people are getting hit, your bones tend to be weakest when they are getting like bent or twisted, more so than just kind of straight on impact, right? Or at least the amount of straight on impact that another person can apply to you. But my guess is that the MMA men and women probably do quite a bit of resistance training. They have a lot of loading that go in. So they probably do have maybe relatively stronger bones than maybe just a regular untrained person. But it would be difficult to kick someone in the shin hard enough to, well, you could break their fibula. Your fibula is basically like a piece of glass. I mean, you can like fall over and break your fibula, but like to break the tibia would be really, really difficult, I would think. So
It's happened.
Kylie, are you an MMA person? Do you like to watch? Do you have dreams of getting in there and doing some of that yourself?
No, not. I just remember I was watching a fight one time, and this guy like kicked another guy. Well, his leg like hit him, but the shin like broke in half, and just like I don't know.
No, I can. That would leave an impression when somebody gets kicked and it like their leg is meant to be going like this, and it's going sort of 90 degrees
Yeah.
from that. So, okay. There was another question? No? Did I miss it? Nope. No other questions about that? You guys are good? Okay. Then similarly, there's going to be some changes that are also going to happen in connective tissue. So in ligaments and especially tendons, they're also going to transmit a lot of that force from the muscles down onto the bones, or they're going to transmit force from one bone to the next. And as a part of all of that, when you stretch the tendons and you stretch the ligaments, that's going to send a signal to them to deposit additional collagen and make the tendons and ligaments get bigger around and more elastic, so that they can tolerate more force across them. One of the hallmarks of things that we see in athletes that have been taking anabolic steroids is we see lots of ligament and especially tendon injuries in them, because what happens is their muscles get so much bigger and so much stronger at a much more rapid pace than they're able to deposit new collagen, especially in their tendons. And so the muscles become too strong, and they're going to rip the tendons and things because the muscles are too strong. So that's kind of a hallmark way in a lot of the folks that are taking anabolic steroids. We've seen a lot of injuries from all of that, especially like in the baseball players back more in the 90s and early 2000s, when it was potentially more prevalent than it is kind of right now. Okay, so the last slide is pretty self-explanatory. It's adaptations to disuse. When you don't do things, everything that changes in a positive direction, like an increase in strength, an increase in muscle size, an increase in bone density, an increase in the strength and the collagen deposition in tendons, all of that goes away. And it goes away very, very rapidly, okay? Within a week or so, you're going to see kind of marked decreases in things. We did a study when I was a PhD student where we had people wear a giant platform shoe, like a 6-inch platform on one of their shoes. We gave them some crutches, and they crutched around for a month. And when they would sit down, they would prop up one of their legs like this, and the platform shoe allowed one leg to just swing. So they basically did not bear any weight on one leg for a month. It's meant to simulate weightlessness and space flight. And over the course of a month, their calf lost about 15% of its size. Their quadriceps lost about 10% of their size, and they lost almost 40% of the strength in their calf and in their quad. So stuff goes away really, really rapidly as that happens. So it can be a big problem. All right. So what we're going to do now is I'm going to so that we have all of this, okay? So with resistance exercise, and we'll see the same thing with aerobic exercise, really any kind, what we need to understand in the place where people mess up the most is in prescribing something called intensity, okay? And so most of the time, we're going to look at our workout program, and we're going to apply something called the FITT principle, or the FITT principle, okay? And so I'm going to open up and share my screen on our PowerPoints, but we're actually going to start towards the end of the PowerPoints because we've done this. I'll talk about a couple of things, and then we'll almost work our way backwards to a little bit of how we figure out what your maximal strength is. But I think starting with why that maximal strength, or knowing it, is important is probably going to be a better way to do this. So let me go ahead, share screen, and we'll pull this up, okay? All right, so if you've had a class, if you've had personal training, or you've had strength and conditioning, hopefully you've seen this idea of what is called the FITT principle. This is going to give us a framework to evaluate any exercise program, be it resistance training or a weightlifting program, or a CrossFit program or an Orange Theory program or running or walking or something, whatever it is, we can use this FITT principle or these FITT principles, and it gives us a framework to look at, are we getting enough? Are we getting too much? And are we kind of hitting the places that we need to with our exercises? Okay. So FITT stands for frequency, intensity, time, and type. Okay, that's the FITT. So frequency is pretty straightforward. That's just the number of days per week that you're going to do those particular exercises. So with what you guys came up with, most of you guys had a frequency of somewhere between 2 and 4 or 5 days per week of exercising, and that's great. That's right kind of in our wheelhouse zone of what we need to do. 5 for some people may be a lot. Okay, I don't know that I would squat or do the exact same exercise 5 times in a week, but we're not too far off with all of that. Okay, for resistance exercise, the time component, we're going to come back to intensity. The first T, the time component, is really going to not encompass time. It's really going to encompass the kind of total number of repetitions for that exercise that I'm going to do. Okay, and so those number of repetitions will determine how long it takes you to do them, but the time thing really is much more applicable for like running or walking or something. So for time though, it would be how many sets am I doing and how many reps in each set am I doing. You can multiply those two things together and get a total number of times or a total number of repetitions that you're lifting that weight on a particular session on a particular day. Okay. For resistance exercise, the type is just what lift are you doing? Are you doing a bench press? Are you doing bicep curls, right? Are you being super bro-ish on a Monday and getting on the cables and doing like flies? When you do chest flies like this with the cables, we can talk about the bros' favorite lifts and why they do what they do. Mostly it's a misguided thing that it thinks it's going to like shape their pecs in a certain way. It really not kind of how that works, but that's just what type is going to encompass. Okay, the thing we have to be careful about with type is everyone that starts a resistance training program needs to have a set goal. Okay, there are going to be a goal for, do I want to get stronger? Do I want to make my muscles bigger? And which muscles am I looking to train? And you want to make sure that the type of training that you're doing is going to fit and target the muscles you want to work, and it's going to give you the results that you want at the end of whenever your training period is. Okay. So now let's come back to the one that people mess up the most. Okay. Most of you guys did a very good with your frequency, your time, your kind of number of sets and reps that you were putting in there were very good. Several of you, we were talking about doing leg exercises. A couple of you put like quad specific things or glutes. So using my butt, we could do some calf raises, another bro favorite in there. All of those things would hit our legs. That's great. Okay, you guys did really well with that. The place where the vast majority of programs fall short and the place where the vast majority of people that train don't kind of maximize what they're doing is when they're looking at what the intensity of that exercise is going to be. Okay, at what the intensity is going to be. So for resistance training, intensity is going to denote for us how much weight are you lifting in each given repetition. Okay, how much weight are you going to lift? So if I'm squatting, am I going to lift? Am I going to have 100 pounds on the bar? Am I just going to squat with my body weight? Am I going to put 200 pounds on the bar or 500 pounds on the bar? Okay, that is going to determine for us the quote unquote intensity. And intensity is the thing that is the most commonly misprogrammed and probably underestimated portion of a resistance training program. You can also argue that intensity is the single most important piece. If you want your muscles to get bigger and stronger, the intensity has to be correct. Okay? So the single best way to prescribe intensity is we need to know the maximum amount of weight that you can currently lift, okay, for a given muscle group in a given kind of exercise. All right. If we know your max, then we can prescribe an amount of weight to lift as a percentage of that max. Okay. So let's just say I can do a squat with 100 pounds. My max is 100. And we would say then I want to work out at, say, 80% of my max. I want to try to do 8 repetitions at 80% of my max. So then you would take 0.8, multiply it by 100. The math is very easy for that one. So you would need to put 80 pounds on the bar, and you would do your 8 repetitions, or try to do your 8 repetitions with 80 pounds. Okay. As a concept, guys, does that way of kind of doing the math make sense to all of you? You know, give me some thumbs up. I can only see Corey on all of this, but with some of the rest of y'all, I got thumbs up and things. Okay. Now, as we do this, okay, there's a relatively, I think, intuitive understanding that the closer to the maximal weight you're lifting, the fewer number of times you're going to be able to do that lift, right? If 100 pounds, I can lift 100 pounds one time. I cannot lift it a second time, okay? Then if you gave me 90 pounds to lift, I should be able to do it once. I might be able to do it 2, but I'm probably not going to be able to lift it 8 or 10 times. Okay, so there's this kind of sliding scale that the closer your percentage gets to 100%, the fewer the number of repetitions you're going to be able to do. Okay? As a general rule, guys, as a general rule, if you're going to do 10 repetitions for most lifts, that's probably going to fall using a weight of somewhere between 70 and 75% of your max for that lift. 8 repetitions is going to be at about 80%. 6 repetitions at about 85%, right? 90%, maybe 3 or 4 if you're really good at doing something, but maybe as few as 2. So there's this kind of sliding scale. If anybody cares, you can just Google, okay, number of reps for a percentage of max, and you'll get all of these tables. And there are tables that are laid out that, you know, it looks this way for a bench press, and this way for a squat, and this way for a power clean, like picking different exercises. You can look those things up, okay? So for those of you saying you should do rep ranges between 8 and 12 reps during a given set, that would give us that we want maybe somewhere between 60 and 80% of our maximal weight. We want to lift somewhere in that range. That's going to slide us around between 8 and 12 reps. Okay? The thing that most people do that's bad, and I'm as guilty of it as anybody around, is we don't know what our max on a lift is. And so we just pick a weight and we lift it, and we can do it 8 times or 10 times or 6 times or something, right? And so we did it. I did it 8 times, and then I just stopped. And then I did that again, and I did it about 8 times, okay? So what tends to happen when we do that is that we underestimate the amount of weight that we need to lift, okay? Underestimating is the single biggest mistake, and the single biggest way or largest way that you will not increase your maximal strength and you will not increase in muscle size is because you're not lifting enough weight for the amount of reps that you're doing. Okay, does that make sense, guys? Y'all understand kind of how we're doing all of that? And in many ways, that's the reason why, if at all possible, if it's safe, if it's at all possible, we always want to try to assess what your maximal strength is and then use that to prescribe how much weight you're going to lift in subsequent days. And the thing that we need is, once you get stronger, over, say, the next few weeks, we need to always come back and reassess your maximal strength again, so that we can then make sure that if we need to be lifting 80% of max, well, as your max goes up, then your 80% value is going to go up. And so that way you can always make sure that you're lifting a sufficiently heavy amount of weight and that you're getting the maximal amount of stimulus to make your muscles get bigger and stronger. Okay? Does that make sense?
Yeah, I have a question.
Of course, Judy, fire away.
So, is there like a percentage we should be aiming for, or do we just go based off of how many repetitions we're wanting to do and then figure out the percentage? Or
So that's a fabulous question. That is maybe the question of the day is, well, how do I know what to do, right? Like, how much should I be doing? Should I be doing 90% of my max, or should I be doing 70% of my max, or something like that, okay? So here's what I can tell you guys about all of that. There are two things to keep in mind, okay? The closer, if your goal is, I will say that it all depends upon what your goal at the end of the day is going to be, okay? If your goal is to be as quote unquote strong as you can, to be able to lift the largest amount of weight possible, maybe because you're having a competition with your roommate, or you're a power lifter or something, and you have something on the line for all of that. If you want to be able to lift the largest amount of weight possible, then when you go and you do your resistance training, you need to lift heavier weights for fewer amounts of repetitions, because the nervous system is going to get better at lifting a heavy weight and making that maximal strength go up by practicing that, okay? If conversely you don't care as much about just how strong you're going to get, then there may not be a need to lift at 90 or 95% of your 1 rep max, okay? You may be fine lifting somewhere between 60 and 80% of your max and just adjusting your repetitions accordingly to all of that, okay? Does that kind of answer your question, Judy?
yeah, thank you.
So there is an addendum to what I just said, okay? And I'm going to say something that in the field of exercise physiology is somewhat controversial, somewhat, okay? For those of you that train quite a bit, I'm going to tell you something that I think the data shows us that runs in the face of what is traditionally thought of as resistance training programming, okay? And I'm not saying that the other way of programming is bad or that it's wrong. It just may be a little bit overcomplicated. So if your goal is to gain strength, you just need to lift a heavy weight as many times as you can. Lift close to your 1 rep max. The evidence is very clear. That's how we get as strong as possible. A lot of people, though, what they want is they want to maximize the amount of increase in muscle that they get. They want to be as big as possible, okay? They don't care that much. They're not a power lifter. They might even be an athlete. They just want to be big, okay? And so they will say, well, how should I train to get my muscles to be as big as possible? There's a lot of thoughts. There's been a lot of research done on all of this. My answer is that it doesn't matter that much as long as when you do a particular set, every time you're lifting, that you lift the weight in each set until you cannot lift it anymore, okay? That if I'm shooting to do 8 repetitions, I need to do my 8 repetitions with 80% of my max. If I can do a 9th repetition, do the 9th one. And then try for a 10th one. You want to lift until you cannot go for another repetition. And if you do that in each set, there's pretty good evidence that the number of reps in a set, if you go, we call that idea failure, that if you go until failure in each set, that whether you're doing sets of 15 or 30 or sets of 4 or 3 or something, that the amount of hypertrophy that we see over the course of 8 or 12 weeks with training is relatively similar. Okay, it's relatively similar. If you are a proponent of the National Strength and Conditioning Association, people will talk about, oh, I'm in a strength training phase. Your strength phase, you lift heavier weights. They'll say, I'm in a hypertrophy phase. You tend to lift 8 to 12 reps, 4 or 5 sets, and you do these kind of short rest periods in between, or something else where you're, more of a kind of higher rep thing. There's some scientific rationale behind where those things came from, but we have some evidence over the last 5 years or so that it may not be that complicated, that the key thing is if you lift until failure. If you do it that way, they have data where people will take like a 10-pound weight and do like curls with a 10-pound weight and do sets of 50 or 60 and go to failure, and they get an equal amount of hypertrophy as in their other arm they're lifting like doing like 3 reps, like 3 sets of like 3 reps or something. So we think there's something about working the muscle right up to the point of failure that may be the more important thing for driving hypertrophy. Okay. Now, from a practical standpoint, I tell people pick a weight that you can lift 6 to 12 times. Make sure that you lift it until you can't do it anymore. It's a little easier to get to that point of failure with a little heavier weight. If you've got a really light weight that you're going to have to lift 30 or 40 times, you're going to get bored while you're doing all of that. And it's just easier to get to failure with a little heavier weight. But stay in that 6 to 12 rep range, 60 to 85% of your max. Go to failure, be consistent with that, and you're going to get a lot stronger, and you're going to get close to maximizing your muscle gains. It doesn't have to be super duper complicated. You read them. Anybody that wants to make it more complicated than that is trying to sell you something. A magazine, their workout program, their particular supplement, whatever it's going to be. You can go pick up a Muscle and Fitness magazine. They have all these bodybuilders. I do 22 sets of 1.5 repetitions to like blast my biceps and make them giant or whatever. What they don't say is that they're also taking steroids, and that's why they're giant. Or they're also in the 1% of genetic responders. So it doesn't matter what they do. They're just going to be giant anyway. Okay. Whereas the rest of us mere mortals that aren't taking roids, we've got a little bit of adjusting to kind of do it. Okay. All right. Does that make sense, guys? Do you understand the idea of lifting to failure, and that we're going to kind of adjust intensity based upon the number of reps that we want, and we need to know what our goal is? A lot of workout programs, they don't have a goal. Do you want to get a lot stronger? Do you want to get bigger? We don't really know. Okay. And remember, as I told you guys yesterday, most people are only going to get 15 or 20% bigger muscles anyway. So it doesn't matter. You're not going to get that big. So don't worry about, I got to lift a heavy weight. I'm going to look, I don't want to look super bulky or mannish and, something like all of that, which is what I get from some women. I think we're beginning to kind of change some of that in society a little bit. The idea of, sort of that muscular is attractive and healthy and all of those things, I think that's a good kind of body image type of thing. So there we go. All right. The other piece of this, the other myth that I will bust today, doing more than 15 repetitions on something doesn't really help you increase your maximal strength very much. You're just getting better at lifting that weight, whatever that number of times is. So if you're doing, I don't know, a very light weight and you're doing like sets of like 20 or 25, one, you're not getting much stronger. You're just getting better at lifting that weight that many times. And the other big misnomer is that doing lightweight high reps does not help you lose fat. It does not make your muscles appear leaner or anything else. That's the other big myth that seems to be associated with that. I'm going to do lightweight high reps to look cut or to look lean or something. No. You look cut or lean because you went on a diet or you went for a run and you don't have any subcutaneous fat there. So that's the other piece of all of that. Okay? Questions, comments, concerns? You're all going to go do some heavy lifting today, yes?
Does that mean that drop sets are a scam? They're not real.
So I don't know that they're a scam, Preston. What I would just say is that doing the drop set, all you're doing is you're lowering the weight in an effort to try to be able to do a couple of more repetitions. You're still generally trying to go to failure. Sometimes you need to do a drop set if you're gonna, I killed myself on my first set. Now to be able to get 8 reps again on my second or my third set, I've got to drop some weight. I mean, as long as you're taking that set to failure, you're probably fine. To be really honest, if you're doing 3 or 4 sets, as long as the very last set goes to failure, you're going to get pretty close to the same kind of adaptations. But there's nothing sort of anabolically special about doing a drop set in comparison to not doing a drop set. That we are aware of.
Okay, so when we're doing it to failure and like we're doing multiple exercises, so would you just do to failure each exercise, or would you do it just like at the very end, like you don't feel your arms anymore?
I would do each individual exercise. So, and we'll talk about that. We probably will get to that on Monday, but we will talk about, there's some recommendations on, depending upon what lifts you're doing, like the order, kind of the more optimum order to do things that you want to do, larger muscle groups and movements that cross more than one joint, kind of multi-joint movements. So you want to do a squat before you do a knee extension or something, or you want to do like a lat pull down exercise like this that works your back and your shoulders and your biceps before you would do like just a bicep curl. You want to do the bigger movements, the more complicated movements first, and then do the smaller muscle groups, the simpler movements second. A lot of that's from it helps prevent injuries and things. You don't want your biceps to already be tired by the time you're going to do your lat pulls, and things like that. But yeah, I would try to go to failure with all of them if it was me. So, but that's really interesting. We don't have a lot of research on things like that, because most of the research, we just isolate a single muscle group and you just do like 1 or 2 exercises to hit those muscle groups. We don't do a lot of research where people do like whole body exercise and we see kind of the interaction of all of that stuff across multiple muscle groups. So take what I say with a grain of salt. Corey, what's your cat's name?
This one's name is Pumpkin. And I know everybody's like, oh, but she's not orange. It's because I got her on Halloween.
Ah, yes. Okay, well, one of the things you asked me earlier today, what you missed on the first day, was you missed the picture of our cat who is also named Pumpkin.
Really?
She's named Pumpkin because she's orange. So anyway, that's pretty fascinating. Okay, so guys, I'm going to back up and talk a little bit about assessment of maximal strength and kind of why we might want to know that beyond just doing the training principle here, and then we'll talk about the 2 assignments that we're going to get started over the weekend. Okay. All right. So let me minimize you guys down and go backwards to the very start here. Okay, so my assumption is that from anatomy and phys, you guys have talked about agonist and antagonist and synergist muscles. This is just ways that we're going to describe whatever muscles are being used in a particular lift or for a particular movement. Generally, when we do an exercise, we're trying to target the agonist muscle. Okay, there are these different kinds of muscle actions. So when you pick something up, generally that's a concentric or a muscle shortening action. Lengthening when you're setting the curl back down, that's an eccentric action, and then holding it steady is going to be isometric. We could spend an entire week talking about the intricacies and the differences in these kinds of contractions and why they may or may not be super important. But I just kind of want you guys to know what it is that they are, okay? Okay, so when we test how strong you are, all right, which is what we would normally do in our first lab, I'm going to have you guys do a couple of things at home from the lab, but what we're trying to get at is this test of your strength is called muscular fitness. Okay, this is one of our components of physical fitness. This is going to be one of the things that can potentially determine mortality rates. Okay, so muscular fitness usually has two components. The first component is just strength. Okay, the most weight you can lift for a particular movement. Okay, and then the second component is going to be what we would call muscular endurance, and this would be the number of times that you can have some sort of sub-maximal weight that you can lift. Okay, typically muscular endurance you would think of as this is the push-up test that you guys are going to do, or the sit-up test that they do as part of military admissions that you guys probably did in junior high or elementary school as part of the presidential physical fitness test. Okay, things where for the most part you're going to be able to do more than say 12 to 15 repetitions. Okay, the importance of testing muscular fitness is that it lets us track our progress and see how much stronger we're getting. It also lets us kind of prescribe exercise for training programs. And the other maybe less thought of, and why it is really important for a lot of our majors for what you guys are going to go on and do in your lives, is it helps establish weaknesses and imbalances between muscles or between sides of the body. If you want to be a physical therapist, or you want to be an occupational therapist, or in a lot of instances, even if you want to be a PA or an MD, being able to establish that a person is stronger on one side of their body than their other, that can give us insight into what's wrong on one side, right? Where is something wrong? How is it manifesting itself? So we need to intervene with that muscle group on that side of the body. And then we want to work with that side until it is as strong or much closer to being as strong as the contralateral side. Okay, so any of you that shadow physical therapists, which I know several of you are doing this summer, a lot of times it may not be done in a very formal way, but it's like, here, I've got this, like push on my arm or something. Okay, that's going to be kind of how we can use all of this. All right, so we've got some definitions. Those are going to be there. The health benefits of muscular fitness, you're going to have more muscle mass. That's going to be really, really good. That's going to help from a bone mineral density standpoint. The training that you do to improve your fitness also improves your bones. So you have more muscle, which is good. You have stronger bones, which is going to be good. One of the benefits of having more muscle, having a higher metabolic rate, is that it really, really helps with something called glucose tolerance and insulin sensitivity, which we will talk about when we discuss type 2 diabetes. Okay, people that have more muscle mass are going to be less likely to become a type 2 diabetic. And if you already are a type 2 diabetic, if we can increase your muscle mass by having you do resistance exercise, then we can also help control your symptoms by doing all of this. And so this is one of the areas and one of the ways that exercise is really, really beneficial, especially for diabetes. Okay? All right. So moving on, we're just going to do this. So here are the scary data. And one of the ways where we have to be careful about the stories that we tell with data. What you guys see in front of you are some data that tell us that strength, and this is going to be leg strength. So this is a leg press. So you sit in a sled, and you put your feet up in front of you, and you push weight up using your quads and your glutes. Okay, so your thighs and your butt. You're going to push weight with this. So they had a bunch of people do this, a bunch of older adults do this, and they measured how strong they were, and then they followed them, okay? They followed them for, what's that going to be? They followed them for 6 years, and they figured out how many of them died over the course of that 6-year period of time. and they broke them into groups. So you had here on the left, okay, we have the men. On the right, we have the women. And each of these lines represents what we call a quartile. So we grouped the top 25% of men for strength, the kind of next 25%, and then the next 25%, and then the lowest 25%. So we have our strongest men were here in this top line, our weakest men were here, and then we had these other ones in the middle. So they're kind of grouped basically. Each line represents a kind of 25% quartile based upon strength. And then as we moved out here across the months of our 6 years, what you're seeing then is as the line moves down, that's going to lower the percentage of people that survived out to that point. So in our men that could lift less than 90, this is in Newton meters, which is just, we could convert that to pounds. It's going to be less than, it's about 90 pounds or so. Only about less than 70% of them actually made it out to the 6-year mark. Okay, so about 30% of them died over the course of all of that. Whereas the top 25% of men, the men that could lift more than 170 pounds to start with, only about 5% of them died over the course of that. All right, and we see similar things in the women. So what this tells us basically is the stronger that you are, okay, the stronger you are, the greater the chance it is that you're going to live a longer period of time. Okay. So this is leg strength. Big muscles in your legs, muscles you use to walk around and to get up and down stairs and to carry groceries and things like that. It might make some sense that as that goes away, that your health is getting worse. Would it freak you guys out if I told you that there are very, very similar data for doing grip strength, okay? For doing grip strength. So I'm going to show you guys a video. We would normally do this in lab, but you put a thing in your hand and you just squeeze it. It's the same thing. If your grip strength is larger, you will live longer. If your grip strength is less, you're not going to live as long. And all that's telling us about is what's going on here in these muscles in your forearm and everything, okay? So this is one of the areas where we said that it's correlated, but it's not a causative thing. You're not dying because you've lost your strength per se. It's just that as your health begins to decline, you become more sedentary. That leads to other problems and a decrease in strength. So strength is predictive of survival. Right? For most of you guys, again, you've got about 10 more years. By about 30, most people have peaked they've reached their peak strength for their life. And so all you're going to do is get weaker over the rest of your life. So my encouragement is get out there and lift some weights and do some things now. Okay. All right. So we've talked a little bit about this already, why we want to measure strength, how that's important. Talked about the factors that affect all of these different kinds of things. So if we want to test it, okay, the thing that we are going to do, and I'm going to show you guys some videos of this, and then you're going to see data from a previous class as part of your lab, is we're going to do something called a dynamic strength test. Dynamic just means movement, okay? Very often, this is called a 1 repetition maximal test. It's the most weight that you can lift for 1 single repetition, okay? It's the most weight that I can curl up with good form 1 time, okay? That's a dynamic strength test. Doing the grip strength test that we do is very often called an isometric test because you squeeze the thing and nothing actually moves. You're squeezing, but the dynamometer doesn't move. I'll show you guys again a video of all of that. Isometric testing is a little bit different than dynamic testing. It has some other, they all have some different advantages and disadvantages, but for prescribing resistance training, doing the dynamic 1 rep max test is the gold standard of what we want to do. And I've got a video that I have found, a YouTube video that I'm gonna put on, that I'm gonna post for you guys to watch. That's gonna walk everybody through the kind of generally accepted procedures for doing all of that. Okay, how you want to warm up, how we want to judge if the person is doing the lift correctly, how you decide how much weight to add, etc., etc. All right. We would normally do that in lab, but I'm not going to have you guys do all of that. What you guys will do, because you can do it at your house or your apartment, is you guys are going to do these field tests for muscular endurance. We normally do them as part of lab, but this is the only thing y'all are going to do. You're going to do a push-up test, okay, where you're going to do as many push-ups as you can consecutively. Then you're going to also, they call it an abdominal curl. It's basically a crunch, okay? And you're going to do as many crunches as you can in, I think it's in a minute, with all of that. And you can use how many of those that you can perform in the time allotted, and we can tell kind of where you fall in comparison to other people of your age and of your sex, okay? So one of the things that you will do as a part of lab is you will do these tests, you'll get a number. Let's say I did 31 push-ups. And so you will look up and say, all right, I am a 20-year-old woman. I did 31 push-ups, and so that puts me in the 60th percentile for my ability to do push-ups, and that's, you know, better than average, basically. That's, you know, that's good. It's not great, but it's also not terrible. So there are some tables in the lab where you will find how many you did, find your age range, and it will tell you kind of in relation to a large group of people that are your age and your sex, how you were doing, okay? And we can use that then to decide, okay, I'm pretty good at doing push-ups. I'm really bad at doing crunches, so I should maybe spend some time working out my abdominals and less time working out the muscles that we would be using for doing a push-up. Oh gosh, excuse me. All right. So the last thing that I want to hit on. How are we doing on time? Ugh. Okay. I have a question for you guys. What I want you all to do is, what I want you guys to do over the weekend, I would really like to talk about the idea of what's called the PROS principle. So it's progression, repetition, overload, and specificity. I'd really like to move that to Monday, okay? However, to be able to finish and properly do the resistance training program critique, you need to understand the ideas of progression, repetition, overload, and specificity, because you're going to be asked to decide and look at and evaluate in the program that you found, does it have all of those things, okay? So here's what I'm going to do. For Monday, here's what I want. What I was going to do is I was going to assign the critique today and make it due on Monday. What I will do is I will assign it today, okay, and I will actually push it back and make it due on Tuesday rather than on Monday, right? But it will make what we talk about in covering PROS in class on Monday much easier if you attempt, okay, if you attempt to go ahead and find your workout program and you start your evaluation of it and you read the slides about what PROS are, and you attempt to go ahead and evaluate your program that you found based upon those things. And then we'll talk about it in class on Monday, and then you can kind of use that to check yourself, okay? So I'm going to post in Canvas. I'm going to post very specific instructions with a grading rubric for what I want you to do for this critique. In essence, you need to find a magazine or go online, okay? Type it into the Google machine, and I want you to find an 8 to 12 week resistance training workout program, okay? And I want you to find, if it's online, I want you to like copy the link to it and include that in what you're going to turn in so that I can access it. But you're going to find the program, you're going to read the program, and it talks about the questions and things that you need to answer about it and how to do this in the assignment. You're going to look and see, is this program hitting all of the things that we need based upon the FITT principle? Is it talking about what is its frequency, what is its intensity, what is its time, what is it type, what is its type? Is that fitting in the areas that we think are going to be good based upon the stated goals of that program? You're also going to have to evaluate, does it include this idea of progression? Does it include the idea of overload? Okay, does it include repetition? Are you going very frequently? Does it include specificity? You can look up what those things are in the slides and see if it's got those. Okay. If you're unsure about whether or not what you've found is going to work, then find it and send me the link to it via text or via email, and I can tell you if it's going to work. Here's what I don't want you guys to do. You're going to type this into Google and you're going to say Women's Resistance Training Program. And all of you are going to click on the first link, right, ladies? And you're going to pick y'all are going to pick the exact same program. So what I want you to try to do is nobody can use the first like 2 links that pop up in Google. You got to go down to at least the 3rd one, or God forbid you go to the 2nd page if you're showing 10 results per page. Try to find something else. Okay, guys, do the same thing. Don't just type in how to get big or something. That's probably maybe some women that want to get big too, but try to not just pick the very first thing that you find there. Okay, that's the resistance training program critique, right? The second thing that I'm assigning today that you can start working on over the weekend is going to be lab number 1. So normally for lab 1, we do a 1 repetition maximum on the bench press. We do a grip strength assessment in both hands, and we do muscular endurance using the field test, the push-up test, and the curl up or the crunch or the sit-up test. Okay. What I'm going to do for that is I'm going to post the regular lab that we're going to have. Okay. It has some instructions. I'm going to also post a sample lab report. Contained in the lab are going to be instructions and normative values for each of those 4 exercises. You're only going to do yourself. You're going to do the push-up test and the sit-up test. Okay? So you don't have to take video of yourself doing them, but if you want to, you can. All right? Ladies, when you all do the push-up test, you're going to do the push-up test doing a modified push-up where your knees are on the ground. Okay? There's an explanation for that in the lab. Some of you may be very good at doing push-ups and you want to do them regularly. That's great, but it throws off the normative values. The normative values are for how many of these modified push-ups you can do. Guys, you have to do regular push-ups. Okay? You're going to do those 2 things, and you're going to include your data for that. For the other ones, all right, for the other ones, I'm going to send you an Excel spreadsheet that has data from like the students that did this lab back in the spring. So there'll be like 20 or 25 data points on here's 1 rep max bench press strength. Okay, it's going to have like men and women, bench press maximal strength, left hand grip strength, right hand grip strength, and then it will have number of push-ups, number of sit-ups that they were doing. It will also have, I think, their weight included in there. And so as part of the lab, it's going to ask you all, and we do this to try to help get you guys prepared for capstone and how to work with data. It's going to say, take these data, and for the class's data, calculate the average bench press strength for the women and the average bench press strength for the men. The average grip strength for the men, the average grip strength for the women. Push-ups, it's going to have you do those kinds of things, all right? Then you have to make a graph where you graph, okay, your value, which for 2 of them, you won't have your value. You will not have a bench press unless you know what your bench press 1RM is. If you know it and you can get it, great, but it will just be men's bench press average, women's bench press average. Make a bar graph and show us those 2 things, okay? If you don't know how to make graphs in Excel, go to YouTube, type in how to make a bar graph in Excel. There will be literally thousands of videos, okay? If you watch a couple of those and you can't do it, call me, I'll walk you through it, right? There will be then another graph that you will make for the number of push-ups that the men did, the number of push-ups that the women did on average, and then you'll have a separate bar that will be how many push-ups you did, okay? And then as part of the discussion in your lab report, you will say, I did in general more push-ups than the average woman in class did, or less, or something like that. And I did more or less than the men in class did, okay? It's just a way to get you used to working with some data, making some graphs, and kind of looking at how your values fall in line with what would potentially be your classmates or people like you all that are HES majors that we tested on this back in the spring, and then what the kind of normative values that we have from a much larger population. In general, HES students tend to be a little stronger than regular students. You guys tend to work out more, okay? Does that make sense? Kind of, sort of, maybe, okay? I will post all of those things. I am certain that you guys will have questions. That's okay. Call me, text me, okay? And I will help walk you through. I do not remember from the syllabus when I said the lab was due. Usually we usually do a week in the regular semester from when we finish lab to get the lab report done. So I think I probably had the lab report due on like Wednesday or Thursday of the week. Lindsay, are you looking really quickly?
It says the 17th,
The 17th.
which is Wednesday,
Which is Wednesday. Okay.
Mhm.
We'll keep the lab due on Wednesday, but even though we've pushed back the resistance training critique from Monday to Tuesday. Okay. Because if we don't, then everything just kind of gets backed up on us, and let's just try to keep ourselves on track. All right. Okay. So I know it'll be the weekend, and you're probably gonna have to do some homework and do some work over the weekend, and for that I do in some ways apologize, but it's the summer, and there's just really no other way around it. Just take refuge in the fact that you just have to do one. I have to read and grade all 25 of y'all's for each one of those things. But that's of course my own doing, right? I don't have to grade things if I don't give you any work to do. So I'll manage to kind of hang in there. All right, guys, have a good weekend, okay? Please be safe if you're going out and doing things. Make good choices and good decisions, regardless of what you're doing, right? That means both going out and doing activities, whatever that might be. If you're going to the lake, wear a life jacket, okay? Don't drink and drive. I don't know, other things, right? Don't go hang out with people you don't know and drink around people you don't know. If you do those things, if you're going to go protest or do something, then also wear a mask. If you're going out in public in general, just wear a mask and stay away from people. So, all right, okay, y'all have a good weekend. If you have questions, let me know, and otherwise I will see you on Monday.
Professor Black, are you gonna post a lecture from yesterday and today? I was hoping to rewatch them over the weekend.
Yes, I will. I have yesterday's. I just haven't. I've basically decided, Judy, that I'm gonna put them